Okay, so sorry for the delays. I've had a lot of things to do, and that's why it has taken quite a while for me to make this summary or recap of my previous LN2 session. So like 2 weeks ago, I purchased a relatively large amount of LN2 and I wanted to test, well, the main highlight of the whole testing session was the Z690 platform once again. The 12600K, which did a very good job on water. I first tried my brand new Q6600 CPU, which I obtained some time ago, but it wasn't very good. So I wanted to do a reattempt with the better single core Q6600, which I already covered in my previous video. So not so good end result with the P5E3 Premium, but when I used the Rampage Extreme, I could take back quite a few of the top scores in the single core category. So the only thing I'm missing is the CPU-Z core frequency validation. And for that, I definitely need a better CPU. And eventually, I think I need a better CPU for many of the tests, at least for the single core things. But anyways, so the 12600K, I had a lot of trouble along the way. It took me two whole days to get the 12600K to full pot temperatures. I had a lot of issues with code bug, as well as with like IMC related things, mainly training memory, like posting high memory frequencies and so on. I tried many different BIOS versions and so on. And I think I will make like a proper separate extreme overclocking tips video for the Z690 KINGPIN. But anyways, to simplify all of the things, the latest BIOSes, at least the latest XOC BIOSes and the latest retail BIOSes for the Z690 KINGPIN, they are very good. They are much better than the earlier, like the early beta BIOSes that I had to use for the previous top scores, like with the 12600K and so on. Now with the latest BIOSes for the motherboard, the VDDQ voltage is a lot easier on LN2. So with the earlier beta BIOSes, the lower VDDQ values were usually easiest to post, so values between 1.2 to 1.3. I usually use 1.23, 1.25, 1.26 volts on the VDDQ if higher is not needed. That's usually very easy to post, and I don't get very weird debug codes like 54 or 3F on the debug code over here with low VDDQ value. But on the earlier beta BIOSes, sometimes I had to use very high value to maintain stability in tests like Geekbench 3 and so on, like values of 1.5. But posting so high VDDQ values, even with the newest beta BIOSes or any of the newest BIOSes in general for this motherboard, is very difficult. Sometimes posting 1.5 volts on the VDDQ when the CPU is on LN2, it can take up to 5 minutes. So you can obviously imagine it's quite annoying, and it's definitely not something you want to face. So now with the newest BIOSes, low VDDQ value is generally the best. It's easiest to post and it's the most stable at the same time. Now with the latest BIOSes, if I used very high value on the VDDQ, like 1.45, 1.5, even if I managed to post and boot it after some time, it usually hangs very quickly in tests like Geekbench 3. But 1.23, 1.26 volts on the VDDQ, very easy to post and boot, and very stable in tests like Geekbench 3. And I think the highest memory score I managed to get this time around in Geekbench 3 was like 14,700, I think. So quite good considering that the memories were running on air. Now the hardest part about the 12600K was the code bug, as well as the IMC being very flaky at very cold temperatures. The cold boot bug temperature of the 12600K wasn't that bad. Even after CMOS clear and everything, I could cold boot the 12600K as low as -155 to -158. But then I had very random cold bugs between -170 and -190 with the CPU, and the IMC was also very flaky at very cold temperatures. But when it comes to the IMC, I managed to work around that issue by training the memories I wanted to run as cold as possible. So I could train the memories as low as -175, and that's the advice I would give to anyone who runs this platform on LN2. The the general advice is to train the memory settings you wish to run as cold as possible. This is a common issue with many of these latest generations from Intel. Like many, or very often, we do the first like F10.7 exit somewhere between like -80 to -120. If you train the memories at -80 and then you push for the maximum temperature, so -196, it can happen that the memory becomes unstable. Usually it can be the RTL, so the round trip latency settings that make the configuration unstable. That was very common on the original Skylake as well as with the Kaby Lake. So with Kaby Lake, for example, when we ran the A0 PCB DDR4 memories at 4133 MHz with 12, 11, 11 timings, the stable RTL settings on air and water were like 50, 51, 7 and 7, but when we ran the CPU on LN2 at maximum temperature, the most stable RTL configuration was 49, 50, 6 and 6. And if you try to run the same RTL settings you usually run on water, so 50, 51, 7 and 7, they would always be unstable. And that's the same thing that can happen now, even with this generation. So you always want to train the memory settings as close to the temperature as possible that you are actually going to run the CPU at in the actual tests. So if the CPU has a cold boot bug temperature of -160, try to do the F10.7 exit, so the memory settings at that temperature, even colder than that temperature. So that's what I wanted to say. There's a very fancy feature now in the retail BIOSes of the Z690 KINGPIN called XOC calibration. Check out the in-depth LN2 guide made by Sense from our team for this motherboard, but the XOC calibration is a feature that forces the motherboard to retrain the same memory setting. So it's pretty much the same thing as if you changed one value on the sub-timings. So it will just retrain the memories, the very same memory settings you were already running. So if you want to be sure you are stable at the colder temperatures, but you can obviously do whatever way you want. So you can do the same procedure by just changing one value on the memory settings. But anyways, that's one thing. And now when it comes to cold bug, the usual setting table on this generation is 1.1 volts on the core PLL and 1.1 volts on the add-on PLL and ring PLL to get to full pot temperatures. On this generation, getting to full pot temperatures has been very easy in general. All of the CPUs this far that I've tried have been very easy to go to full pot temperatures with. This particular 12600K has been the first exception. It took me 2 days to get the issue solved. Now, the first issue that I encountered was sadly the custom LGA 1700 bracket designed by Kata and 3D printed by Jocard. I first tried with this bracket, obviously. It could stand the cold temperatures just fine, but for some reason, whenever I used this custom bracket, it would always cold bug, so give like the very standard like hang or a blue screen type cold bug at very close to full pot temperatures, usually at around like -185 to -190. And when I switched back to the standard, so the stock ILM, so the stock clamping mechanism that comes with these motherboards, boom, instant full pot temperatures with the very same settings. So something is happening on the actual socket when I ran with that custom bracket. It can happen that the socket actually bends a little bit. So it can happen that some of the individual pins lose contact with the CPU, and it's actually risky. I was discussing about this thing with KINGPIN and other guys in my team, and Biso, so the famous guy from South Korea who has many of the like 3D world records on the 3D Mark Hall of Fame, he actually killed one of these Z690 KINGPIN motherboards by running the CPUs on LN2 without the stock clamping mechanism. So it's actually very dangerous. So based on these findings, I would recommend anyone who wants to run the Z690, so these Alder Lake CPUs on LN2, to use the standard ILM that comes with the motherboards. The amount of pressure needed towards the pins is huge on this generation. When I clamp down the socket clamping mechanism on this generation, it always feels like something is going to break. There's tremendous amount of force towards the pins with the stock ILM. So something is happening. It could be just this particular CPU because I didn't have any issues with the 12900K, but it's still the safest way to use the stock ILM. So sadly, to get like a perfect lapping finish on this generation, you would have to sacrifice some dead motherboard and you would have to saw the whole socket area away from a dead motherboard while the CPU is clamped in the socket, and then you would have to lap the CPU while it's clamped inside the socket. But anyways, so that's one thing. So by switching back to the stock ILM and using high enough sub voltages on the CPU, I could run full pot temperatures just fine in the end. The values that I really needed on this CPU were, well, mostly the key was to use 1.7 to 1.75 volts on the ring PLL, which is very high, and many people would consider that value dangerous on this generation. So ring PLL on these EVGA motherboards is the same voltage as the PLL termination voltage on the Asus Apex motherboards, and I think it's the core PLL on the ASRock motherboards. I don't know what's the name of the voltage on the Gigabyte motherboards, but ring PLL, usually this far I haven't really needed that voltage that much, but at least this particular 12600K really needed it. So if you purchase the Z690 KINGPIN and you try these CPUs on LN2, and if nothing works for you, if you try high core PLL, high add-on PLL, and nothing works for you, and you are wondering why you cannot reach full pot temperatures, try very high value on the ring PLL. It might help you out as well. The core PLL is the voltage we usually use to move like weird, like clock walls on the CPU. So if your CPU hangs randomly at 6.4 GHz with auto value on the ring on the core PLL, and if you raise it to 1.1 volts, it usually has being able to lift those weird clock walls. The standard value on the core PLL is 0.9 volts, and it's usually raised to 1.1 volts, and the maximum value is between 1.3 and 1.4 volts. But I had the best result at 1.1 volts on this CPU. Add-on PLL might also help you out as well, and the best value for me has been between 0.9 and 1.2 volts. But that's pretty much it. So once I got the CPU like properly to full pot temperatures, I could do very like competitive scores with the 12600K. So I was able to do the global rank 1 world record in the Citybench R20 in 10 core category. I actually did it twice. My first result was 10,180 something, I think, but Splave, so the number 1 overclocker from United States, he had a better score on his USB stick, so I had to run that again, and the second rank 1 score was 10,200 plus, and that's the current rank 1 world record on the 10 core category on hwbot.org. So very good result, and the CPU frequency for that score was like 6.75 gigahertz on the P cores, and E cores, well, I think they were close to 5.4, something like this, between 5.3 and 5.4. Then the second global rank 1 world record score was the GPU Pi 1 billion in the 10 core category as well, at a frequency of 6.85 on the P cores, and I think even the E cores were close to like 5.5 gigahertz. So pretty good. It took me quite a while to get the rank 1 score in the GPU Pi because my efficiency wasn't the best, but I could outclock Zyko and Splave, and I could take down the rank 1 score in that benchmark as well. Now the older Lake CPUs cannot take down the rank 1 scores in the lower core counts like 6 core category and quad core category in the GPU Pi 1 billion. Those are still held by the AMD CPUs like the 5600X Vermeer Ryzen CPU, and the quad core is being held by the 5300G Z690 CPU from AMD. I do want to try the 5300G later on the X570 Dark. For the 6-core category, I don't have good enough 5600X to take down the top score in that one, but doesn't really matter. Those were the only like rank 1 world records that I could take down with the 12600K. I was very close on the Y Cruncher 1 billion in the 6-core category. So Y Cruncher requires AVX512 for the best possible performance. And on these Alder Lake CPUs, you can enable the unofficial AVX512 support by disabling the add-on cores or the E cores. So when you make the 12600K a 6-core CPU from the stock 10-core configuration, you will get AVX512 support. So I could run Y Cruncher 1 billion at 6.7 GHz. So imagine AVX512 at 6.7 GHz. That is tremendous heat. And I could take the rank 2 score in that test. The top score is by OGS, so Stavros and Phil from Greece at 6.65 GHz, but they ran the memories on LN2. Memory performance is very important on that test. So as I only ran the Corsair Vengeance DDR5 sticks on air, I couldn't get high enough performance from the memory side, and that's why I lost the rank 1 score to OGS. But still, I think my score was completely alright. So I can obviously try that again if I want to and put the memories on LN2 as well. Then on top of that, I had quite good results in X2654K, a better result in 6-core category compared to 10-core category, but I couldn't do good enough performance because I didn't have Server 2012 at hand, and it seems that specific test really likes Server 2012. So I think I could do the 6-core top score, but 10-core I really doubt it. So on 6-core category I think it's possible, but it's quite difficult in the end. Geekbench 3, I think I could have a chance on the 10-core category top score, but 6-core no way, because the highest core or the highest result in the 6-core category in Geekbench 3 is at 6.9 GHz by Zergman from Germany, and my CPU definitely cannot do 6.9 GHz on the P cores in Geekbench 3. So 10 cores is definitely like more realistic to try, but it's still very hard as well, and it definitely needs memories on LN2. So that's pretty much it. After the 12600K attempts, I wanted to try 12300 and the G7400 CPUs on LN2 on this platform as well, but sadly I had some issues with the quad-core and the dual-core non-K CPUs on the Z690 KINGPIN, so I couldn't do competitive scores yet with those CPUs. 6-core non-K CPUs are working just fine, and now I have a new BIOS that should fix those issues that I had with quad-core and dual-core non-K Alder Lake CPUs. So I'll get back to you with that topic later on my next video, so stay tuned for that. I will cover some non-K overclocking on water with 12300 and G7400 later. As I couldn't run those, I didn't have that much LN2 remaining, so I actually tried some 980X CPUs. I had 2 new CPUs, but they weren't very good on LN2, like they didn't really scale. Then I wanted to like rerun my best, so the 7.2 GHz 980X again on LN2, see if it's still like alive and well, can it do competitive scores anymore, as it could do very good result, actually better result than ever before on water, like 4.9 GHz plus on W prime on water, but sadly it has very weird form of degrading or degradation. So for some reason that particular 980X cannot stand high V-core anymore on LN2. It can do the very same settings or the very same speeds on water, like 4.9 GHz in W prime with 1.4 volts, but on LN2, for example, if I tried to post and boot 5.2 GHz or 5.4 GHz, that was absolutely fine if I used V-core value of 1.5 or 1.55, for example. But if I raised the V-core to 1.7 to 1.75, like if even if I had cold enough temperatures, it would always give endless blue screen when I tried to boot into the operating system. So for some reason it cannot stand high VCore values anymore, and I tried few different motherboard models. I tried Rampage 3 Formula, Black Edition and X58 AOC, and it was the same story on all of the different motherboards. So it seems, sadly but true, I need to find a new 980X that could have any chance on the single core benchmark record scores, so SuperPi 1M, 32M and PiFast. But yeah, that's pretty much it. That was the end of the whole session. So at least I got the nice results with the 12600K as well as with the Q6600. I really hoped I could have included some non-K like top scores in the same session, and maybe the Z690 5300G, but it seems that I need to try those next time on the next session. I also still want to find some important like old legacy CPUs, so 775 and 1366 CPUs that are very important to me, but it definitely takes some time because you really have to bin a lot of those CPUs nowadays if you really want to have any chance on the rank 1 scores. So stay tuned for those. I will try to get the non-K Alder Lake CPUs as well as the 5300G tested on LN2 as soon as possible. We might also have some LN2 overclocking session together with Joe Card once again, maybe next month, so in April, we'll see. But I will tell more about that later. So I'll get those, and yeah, I'll work on my 775 and 1366 projects as well, and I still have a lot of videos to do, as I already showed you in one of my earlier videos that I have a lot of topics I need to cover. If you like to see these results once again, then please give me a thumbs up and subscribe to my channel. I really hope you like to see my efforts and my work in my like extreme overclocking tests and projects. And if you want to support my work, then definitely check out my Patreon page and maybe join my Patreon Discord channel. And yeah, so definitely subscribe to my channel if you like to see extreme overclocking content like this on YouTube. And thanks for watching one of my videos once again, and I will see you on the next one.